Thank you very much. I think we have some opportunity to interact with the speakers, but if there are other additional questions.
Yeah, actually, my question to Andy, just a follow-up. I know he made the comments that the OpenStack APIs could be used to enhance security, if I quote you directly. Can you say a little bit more, basically, how the APIs will enhance or reduce security?
So today's OpenStack isn't particularly secure as far as I understand this, meaning it came out of the NASA Nebula project, and there's different vendors now who want to adopt this to either rack space, hosting, multi-tenant environments, or to bring it into the enterprise as a private cloud. So the missing piece, in fact, is to make it secure and manageable and add all these features that, say, an enterprise customer would expect as part of a private cloud offering. So this is a work in progress. But what is unusual is just the fact that this didn't even exist a year ago. In fact, there's some other companies out there called Cloud.com and Eucalyptus, I believe, that have been trying to create what I would now call proprietary stacks. And I'm not sure that's going to last very long because compared to 1,000 developers making good progress on OpenStack, it suddenly seems outdated. And at least the rumor is some of these companies will now embrace or adopt pieces of the OpenStack because it's just like Apache was a shared effort to advance web servers faster. This OpenStack effort is becoming a Apache-like thing where people benefit not to have to reinvent every piece of the stack over and over. So it's the classical open source benefit effect where it's a shared development cost and anybody can use it. But you're going to see many different vertical adaptations of that by various companies, ranging from traditional telcos perhaps to new kind of companies to people who specialize in selling this to enterprise IT. It's a wide open field. It's just amazing to me that more than 10 years after Apache, this whole thing plays out again in the context of how to solve this cloud problem for enterprise. And that wasn't even on the scene a year ago, right? I mean, if we had talked about this a year ago, the name wasn't invented yet. So these things can change very quickly if enough people decide and come together to do something, that it actually happens. And this just shows the power of the sort of open source development process and people that want to contribute to these kind of things. This is meant to, if you're an enterprise, you want to know who is using, how many resources, make sure they have the right authority to access whatever data, whatever services. So it's more than passwords. It really is more monitoring and keeping track of what's going on so it can be audited and so on. And again, the technologies or what needs to be done is understood. It just hasn't been yet implemented. But I think this will make an important role in the industry because, again, there never has been an open standard solution there. And this is beyond sort of what people would do internally. It's a lot of work. And again, other people have tried to do this with proprietary stacks, but it is still a lot of work, right? So this is a wide open opportunity for both startups and established companies to leverage this work that's going on. It's very similar to how Linux suddenly took off once it became mature and had enough mechanisms so people could start deploying it.
I thought your presentation was fascinating, thank you. I'm curious about one particular aspect, which is the economics of the solution that you've proposed. How do the economics change with your new model compared to the old?
Actually, it's an excellent point. And the angle I chose to talk about today because of this audience is its ultimate value to cloud computing. It's going to transform the computing. However, when I present to the CIO or many of the data center managers who's still running the data center as a cost center, that's not the angle to go. And they do worry immediately, how's the cost? How's the power consumption? What's the floor space? What this brings? If you look at the legacy multi-tier Ethernet tree structure, look at each of the switch box. Those boxes are full feature. The networking vendor has no choice but to build a self-complete, autonomous, full-feature switching box, whether it's 24 ports, 48 ports, or 96 ports, as one vendor just announced a couple of days ago. But obviously, for any reasonable size data center, you need tens or hundreds or even thousands of these switching boxes to build multiple tiers. Now think about, once a packet, one of the server wants to send a packet to another server for some messaging, you enter the first layer of switching box, your packet get decapsulated, header get examined, and find out what you're trying to do, and quickly put all the header back, and then pass it on to the next tier. What does the next tier do? Exactly the same thing. Open it up. So, oh, you want to go there, and then quickly put the header. So one simple transaction, it will take you 6 or 8 or 10 encapsulation, decapsulations, and yet the only meaningful ones are probably either at the ingress or at the egress. So you can see the legacy architecture, well, we cannot be too critical about it because it's a natural growth out of starting from one single one. And you need more server, more storage, and it goes beyond the number of ports available on that switch, so you bring another switch. Once you have 2 switches, these 2 switches itself has to be connected. So there you go. And when I have enough time to talk about, I have a very fancy slide, just waiting for PowerPoint to build that multi-tier tree structure. We can sit here and enjoy a 2-minute movie. It's fun. But, so the legacy architecture has a lot of waste on this, not just you incur all the electronic cost. A lot of time that's less of an issue. Actually, they burn power, and they incur latencies. When humans deal with it, a couple seconds, you and I don't care. When 70% of the equity worldwide today are being transacted by computers based on pre-programmed algorithms, every microsecond matters. So all of a sudden, these become issues. So sorry for a long answer. The short answer to your question is, yes, if you design from a clean sheet of paper, you can design a data center fabric. You only check the packet once when they enter the fabric, just like when you enter a single switch. No redundant operation, no redundant electronics, which naturally will give you an order of magnitude saving in cost, in power, in floor space. If following the incumbent vendor's wish, they just continue applying additional boxes, cables, line card, patches, software protocol patches to solve growing problems, all you get is accumulated complexity, and you cannot get a significant advantage. I think we have many scholars here. A lot of time, when you really want a fundamental improvement, you have to start a new architecture, and that's what we are talking about here.
Not sure if this is a question or a thought, but I was kind of inspired by some of the stuff that you talked about, Jamie, about the enterprise IT. And I guess if it's a question, it's for you and Andy. If we look at IT today, we all know that it's a problem. We have legacy, we have silos. Messing with enterprise IT takes a long time. We have BPM, we have SOA. Takes years to really do it, and so on and so on. And then if I'm thinking about Alan Kay's talk beforehand, and we had like the small talks in the 70s and the 80s, we had really clean concepts. And as a programmer today using our programming environment, it's a real mess. So it's pretty clear that at some point enterprise IT is just going to move on to the cloud. But we also really have here an opportunity to rethink some fundamental concepts, like how do we do that and really get the interoperability and flexibility and agility that we need. And I'm not sure that there is yet a focus on that. Maybe it's orthogonal to cloud, but I'm very curious to hear your thoughts on that.
I'll start with a perspective. Well, I think what you're alluding to is actually transformation. It's you know, this kind of change is not, as you mentioned, you don't just incrementally change your network. It's a ground-up architectural shift. I think you have to think in the same light as far as the business itself. And oftentimes we have to go all the way back to the business and say, can you rethink the way that work gets done in terms of your business? Or are you after a completely new business strategy, different markets? Your market has moved, that you're chasing, and therefore you've got to now think about different business services, different ways to get your work done within your business, and then see how the transformative services in IT, that new services, cloud-enabled services, et cetera, can apply to the new business that's evolving. That oftentimes it serves as a catalyst for change because it's kind of a top-down influence, a top-down strategy. So that's one of the, when we have these conversations with customers about cloud adoption, we often, sometimes you walk in and you say, and it's a cost kind of driven conversation with IT leaders about taking cost out, virtualization and networking, some incremental changes there on a cost basis. But then the bigger change that really is going to comes with actually a shift in the way that business behaves and the way that business works. That's a different level conversation, and it often is not exactly with the CIO, but with his counterparts and with the CEO and CFO, actually. So that's one perspective on it.
You can just add one more thought here, which is it's really application by application, right? For example, take email. Your email system may work perfectly fine the way it is, or you may look at this and saying, how much money are you spending on email and how much does it really cost to use, say, Google Mail instead? And you will likely find this that Google Mail is actually cheaper than you can do it yourself. And there have been very large enterprises that have recently switched from internal email to outsourcing all the email because it just wasn't worth doing it internally anymore. So that's an example of cost cutting. Whereas trying to move your Oracle database in the cloud, that's a very challenging topic. It may actually be impossible for the next many years because of all kinds of reasons, right? So there's easy low-hanging fruits, and then there is much harder ones that may never go on the cloud for whatever reasons.